Question is, a company is moving a business-critical multi-tier application to AWS. The architecture consists of a desktop client application and server infrastructure. The server infrastructure resides in an on-premises data center that frequently fails to maintain the application uptime (SLA) of 99.95%. A solutions architect must re-architect the application to ensure that it can meet or exceed the SLA. The application contains a PostgreSQL database running on a single virtual machine. The business logic and presentation layers are load balanced between multiple virtual machines. Remote users complain about slow load times while using this latency-sensitive application. Which of the following will meet the availability requirements with little change to the application while improving user experience and minimizing costs? And the options are: Option A. Migrate the database to a PostgreSQL database in Amazon EC2. Host the application and presentation layers in automatically scaled Amazon ECS containers behind an application load balancer. Allocate an Amazon workspace for each end users to improve the user experience. Option B. Migrate the database to an Amazon RDS Aurora PostgreSQL configuration. Host the application and presentation layers in an auto-scaling configuration on Amazon EC2 instances behind an application load balancer. Use Amazon AppStream 2.0 to improve the user experience. Option C. Migrate the database to an Amazon RDS PostgreSQL multi-AZ configuration. Host the application and presentation layer in automatically scaled AWS Fargate containers behind a network load balancer. Use Amazon Elastic Cache to improve the user experience. Option D. Migrate the database to an Amazon Redshift cluster with at least 2 nodes. Combine and host the application and presentation layers in automatically scaled Amazon ECS containers behind an application load balancer. Use Amazon CloudFront to improve the user experience. Correct answer is option B. Migrate the database to an Amazon RDS Aurora PostgreSQL configuration. Host the application and presentation layers in an auto-scaling configuration on Amazon EC2 instances behind an application load balancer. Use Amazon AppStream 2.0 to improve the user experience. Next question is, a company runs a popular public-facing e-commerce website. Its user base is growing quickly from a local market to a national market. The website is hosted in an on-premises data center with web servers and a MySQL database. The company wants to migrate its workload. AWS, a solutions architect, needs to create a solution to: first, improve security; second, improve reliability; third, availability; fourth, reduce latency; fifth, reduce maintenance. Which combination of steps should the solutions architect take to meet these requirements? Select 3 options. Option A. Use Amazon EC2 instances in 2 availability zones for the web servers in an auto-scaling group behind an application load balancer. Option B. Migrate the database to a multi-AZ Amazon Aurora MySQL DB cluster. Option C. Use Amazon EC2 instances in 2 availability zones to host a highly available MySQL database cluster. Option C. Host static website content in Amazon S3. Use S3 transfer acceleration to reduce latency while serving web pages. Use AWS WAF to improve website security. Option D. Host static website contents in Amazon S3. Use Amazon CloudFront to reduce latency while serving web pages. Use AWS WAF to improve website security. Option E. Migrate the database to a single AZ Amazon RDS for MySQL DB instances. Correct answer is option A, option B, and option E. Use Amazon EC2 instances in two availability zones for the web servers in an auto-scaling group behind an application load balancer. Migrate the database to a multi-AZ Amazon Aurora MySQL DB cluster and host static website content in Amazon S3. Use Amazon CloudFront to reduce latency while serving web pages. Use AWS WAF to improve website security.